we have seen that instructions are of various types. One is memory related, other one is register related, and other one is IO related. And whenever you have these memory reference instructions, you have to go to the memory and get the operand, and sometimes you have to go to the memory 2 times and get the operand, right, in case of indirect addressing. That is why if you observe it, the time required for those instructions were like 5 clocks, 6 clocks, 7 clocks, like that. But in case if you don't have to use those memory reference instructions, if you need to just use the register reference instructions, which means if the required operand is already present in the register, or if you are trying to access only the registers, in any case you need not go to the memory. In that case you need not fetch the operand, and so you will be able to finish the instructions fast. So till now we have seen that we are using T0 and T1 for fetching and T2 for decoding, right? And in case of memory related instructions, we are starting from T3, this calculation of effective address. So in case of register reference instructions, we need not use this T3 for effective address at all, because there is no need of going to memory. So from T3 itself we can start executing, and in T3 itself we can finish executing. That is the beauty of this. So that is why referring the register or doing something on registers is fast, isn't it? If you are not involving memory, it is fast. So all these instructions are reference register reference instructions, and they all will get completed in just 4 cycles. Fetch here, decode here, execute here, over, nothing else. Got it? Now let's see how to design the hardware in order to enable these instructions at that particular time. So all these instructions have to be enabled when the timing signal is T3, isn't it? T3, fine. Then how can I identify that they are register reference instructions? Opcode only, right? So if the output of the instruction decoder is all ones, 1 1 1, which means if the output is D7, right, and I is 0, I means that the first bit of the instruction, if that is 0 and the time is T3, then all this means this represents the register instruction mode or register reference instructions. In this case we can now distinguish which type of instruction it is based on the remaining bits. So you can just see this one, you'll understand better. If you are looking at the instruction format, it is going to have, so from here 0 1, okay, 16 bits. So assume that it is a 16-bit instruction. That is what we have been using. And now in case of this register reference instructions, the first bit will always be 0, and this is nothing but it is used to represent the address mode in case of memory, and otherwise it is used for this distinction. Okay, now if you see this, which means if I equal to 0, this is the symbol, and this represents 7, and if it is D7, then we can think of it as register reference instruction. Got it? 1 1 is nothing but D7, right? And now after getting into it, when should we execute it? When the timing signal is T3. Therefore these 3 are going to give us the required circuit like this. If you give it, one is D7 and other is I prime and other is T3. This is enough. Now it means that it is a register reference instruction. What type of instruction specifically it is, that depends on the remaining bits, right? So these 12 bits, let's call this one as B11, let's call this one as B10, like that. Okay, and now first one is complement accumulator. CLA means complement accumulator. We have already seen it. So what should we give to this? One more bit. So that bit is nothing but this particular B11, right? So from here if I connect this B11, this bit will be connected, which means from instruction register directly if I connect this to this logic, now this particular signal should be applied to the accumulator to complement it. Alright, so let us say the accumulator is already configured in such a way that it has the required circuit to complement it. Now this input has to be given to trigger that hardware. So once you trigger it, accumulator will be complemented. Similarly, complement E, this one is complement E. For this one we have to give B10, which means, see, for this first one the bit that will be one is B11, for this one B10, for this one B9, B8, B7, B6, B5, B4, B3, B2, B1, B0, right? So correspondingly we'll just change it. So if it is the first one, if this is 1 and if it is all zeros, then we can assume that it is complementing accumulator, or if it is 1 and if all the remaining are zeros, it is complementing E, or if this is 1, right? And next one is CMA. CMA is the first two are clear. CL means these two are clear. These are used for clearing the accumulator and clearing E, and these two are complementing accumulator and complementing E, and this is circular right and circular left. So correspondingly, how do we identify them is just by looking at these bits. But anyway, all these operations they can simply be done just by using one cycle, that is T3. Got it? So what I mean to say is, any of the memory, this register reference instructions, they all require just 4 clocks. In 4 clocks it will be over, and the hardware used is this one. So we take these 3 inputs and we just take one by one, right? So it doesn't mean that we have to take one by one. So there will be all circuits present, one for B11 and one for B10 and one for like this. Got it? Like this, and all of them are going to get the same, right? So which means for every instruction the hardware is going to be ready. If that particular instruction appears with the exact mode, and if that particular timing signal arrives, then automatically this will go and trigger the hardware, and that instruction will get finished. So it is going to be finished in 4 clocks. Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%. But all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkey's ranking is 400. If you are happy to get into IIT Roorkey, then getting into universities better than IIT Roorkey is easier compared to getting into IIT Roorkey. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.